If we are thorough with this signals and systems course, we can easily learn the concepts in communications course. But if you are not studied this course, so what are the concepts we required in this communications course? So that I will tell you. So the basic concepts of signals, right? If you know, you should know what is a signal, types of signals, and what are the basic signals, right? So generally, what are the types of signals practically we will get, right? So that I will consider as signals and their properties. Signals and properties. Signals and properties of signals, right? So these are the basic concepts. So first I will start this analog communications course from this concept, signals and properties of signals. Then we should know the frequency domain representations. That is the basic one. The first one is Fourier series, right? So very important concept. We may not get, or we may not study this analog communications course using Fourier series, but to know the Fourier transform, we should know the basics of this Fourier series. So we will only spend a small amount of time to study this Fourier series. The next one is Fourier transform. If we don't know Fourier transform, or if you are not clear with this Fourier transform, you cannot learn this communications course. So what we will discuss is, so what is the Fourier transform, what are the formulas for this Fourier transform, and properties. So properties are very important. Those properties we are going to use in analog communication, right? So these are the three basic concepts from this signals and system course. We can add one more is sampling theorem. Sampling theorem. Anyway, the first topic in digital communication is sampling theorem only. We should know this sampling theorem to study the digital communication, right? If at all it is coming in the analog communication, so I will explain the sampling theorem there. So what we will start this analog communications course is, so what is a signal, right? What is the properties of signals? So if you know these prerequisite concepts, so we can easily learn this analog communications course, right? Now we'll start with the signal. So very simple definition of a signal, everyone knows. So many textbooks give so many different definitions. I will give a very simple definition. Now we'll see the definition of a signal. So very simple way we can say is, it represents a physical phenomena which contains some information. So signal, so it is going to represent, so it represents a physical phenomena. So we can take example like a room temperature, pressure or speed, etc. So physical phenomena which contains some information, that is the room temperature. So how the room temperature varying with respect to the time. So when we say at 9 a.m. what is the temperature, next at 10 a.m. what is the temperature. So it is having some information, right, how this temperature varying with respect to the time. Now how can we represent a signal? Or we can say, in a signal, this information, so information in a signal, it will have some patterns of variations. So these patterns will vary with respect to some independent variables. So information in a signal is patterns of variations with respect to some independent variable, with respect to some independent variables. So these variables can be a time, space, distance, etc. So independent variable means time, space, distance, etc. So very simple is, or we can have a signal which contains some information, or it represents a physical phenomena which contains some information. So this information is like a patterns of variations with respect to some independent variables like time, space, etc. So this is the basic definition. Now, how to represent these signals mathematically? So mathematically, the signals can be represented as a function of, again, independent variables. These independent variables can be one independent variable, two independent variables, etc. Right. So I hope it is clear. So what is a signal? So how we are going to represent this signal mathematically is, so signals mathematically represents as a function of one or more independent variables. Now, if it is a, suppose some function is a varying with respect to the only one independent variable, that is time, it is called one-dimensional signal, right? This can be vary with respect to the two independent variables. Suppose with respect to some distance x and a time t, then we can consider this is a two-dimensional signal. So we can have three-dimensional signals also. So it should vary with respect to three independent variables. So generally the video signals, it's a three-dimensional signals. Images, pictures can be two-dimensional. The normal signals, the physically available or physically representing is the one-dimensional signals, like the temperature variation with respect to the time, or the voice signal. So my voice signal, it varies with respect to the, again, the time. So audio signals, again, one-dimensional signals. So one-dimensional signals are like audio signal, voice signal, or temperature with respect to the time, etc. So temperature with respect to time, right? So these are some examples of one-dimensional. So two-dimensional like pictures, that is images, three-dimensional video signals, right? So this is about a signal. So I hope it is clear. Now, in communication or in signal systems, maximum we will discuss only one-dimensional signals like unit step signal, ramp signals, etc. So in communication we may discuss the two-dimensional view also, but mostly it is one-dimensional only, right? Now, after learning this, what is the definition of a signal, next we will see classification of signals. So classification, so very important. So generally the students will confuse with what is analog signal, continuous time signal. So first we will see those classifications. Classification of signals. For the time being, I will discuss only two classifications. First one is continuous time and discrete time signals. Discrete time signals. Sorry. Second one is analog and digital signals. We can have another classification like periodic and non-periodic signals, deterministic and random signals, or probabilistic signal, energy signal, power signals, etc. But first we will analyze or learn what is these two classifications: continuous time, discrete time signals, analog and digital signals. So many students will have doubt that can we say continuous time signal is an analog signal, or analog signal can be called as continuous time, etc. So I will clarify those doubts now, right? So only two classifications, but there are so many, so that we'll see when it comes. So when we discuss periodic signal, non-periodic, etc., so we'll see later. Only we'll discuss these two types or classifications. So first we will see continuous time. And now what is a continuous time signal? So very simple, a signal which is specified for a continuous values of time is called a continuous time signal. So it should vary continuously with respect to the time. So a signal which is specified for a continuous values of time, for a continuous values of time. So we will represent with respect to the t. So a signal which is specified for a continuous values of time is called a continuous time signal. So is continuous time signal. So example, very simple, voice signal, audio signal, etc. So which varies with respect to the, so continuously with respect to the time. So there is no breaks actually. So if I am speaking, so my signal will have some the variation something like this, continuously varying, right? So it's an example of continuous time signal. Now how to represent this? So the example I can say audio signal, a video signal, that is output of the television, right? So audio means output of a telephone, right? So our voice, so audio signal, video signals, etc. So how to represent this? Only one notation, I can represent by x of t, right? So this is a continuous time signal. But how to draw, right, graphically the continuous time signal? So horizontal axis or x-axis represented by time t. So here my signal x of t. So how this fellow varies? So it should varies with respect to the time. So the amplitude, the y-axis or vertical axis represents amplitude of a signal. So it is varying continuously. See, at each interval of time, or at every instant of time, actually every instant of time there is a value, right? So that's why it is called continuous time signal. So one more example I can give. So can I say this as a continuous time signal? Yes, because see, every instant of time there is a value, but it is not varying. Still it is called a continuous time signal, right? So after another classification you will come to know it is a continuous, but it is called digital signal, right? This is also continuous time signal, this is also continuous time signal, right? So I hope it is clear. So what is a continuous time signal? A signal which is specified for a continuous values of time t. So examples: audio signal, video signal, x of t. How to represent? So these are the examples or graphical examples, right? Next, what is a discrete time? Very simple. A signal which is specified at discrete intervals of time is called a discrete time signal. So it should not vary with continuously. So a signal which is specified at a discrete values of time t are intervals. So discrete intervals of time is called a discrete time signal. Discrete intervals means at discrete, or we can say at integer levels. So first we will see what is the example. Very simple. So temperature variation in a day. So at 6 a.m. what is the temperature? 7 a.m. what is the temperature? 8 a.m. what is the temperature? Or we can say monthly sales of a company, right? January month, what is the sales? Next February month, what is the sales, etc. You may have seen like this. So example, temperature with respect to time, right? Temperature versus time in a day, or monthly sales of a corporation, company. So these are the examples, but how to represent graphically, that is important. Right? So at discrete intervals of time, so this is a discrete time signal. Examples, so temperature, how this temperature varying with respect to the time, or anything which is varying with respect to discrete intervals. So representation, so these discrete intervals will be represented by the n, right? The time axis will be represented by n or k, we can take any variable, which can be, the values will be like 0, 1, 2, etc. Can we take negative signs? Yes. So minus 2, minus 1, 0, 1, 2, etc. So this is the integer values or discrete intervals. Now how to represent a signal? So we can represent like this, or we can represent like this also. So anything we can use. Now I will use generally this x of n. So how to represent this? Very simple. This is time axis n. We should not represent t. T is always continuous. So this is x of n. Now at each interval or at discrete intervals like 0, 1, 2, 3, minus 1, minus 2, etc. we should have some value. It may be 1, here it may be 2, here it may be 0, here it may be minus 1, here 3, here minus 3, etc. So at discrete intervals there is a value of a signal. So this is the example of a discrete time signal, right? Now one more is there example. I can represent something like this also. Again x of, suppose at 0 there is a 1, at 1 there is a 1, at 2 and 3 there is a minus 1, minus 1. This is also called a discrete time signal, but the name is, it is a digital signal, right? So that also we'll see later. This is a discrete signal, this is also a discrete signal, right? So after we discuss another classification, I will give the summary so that you will get more clarity on continuous time, discrete time and analog and digital. So I hope it is clear. So discrete intervals of time, the signal varies. So we can have only two levels like 1, minus 1. We can have multiple values, right? If it is having a multiple values, we will say it's an analog. If it is only having fixed levels, we can say it is a digital signal. So the next classification is analog and digital signals. Analog and digital digital signals. So what is an analog signal is? A signal whose amplitude can take on any value in a continuous range is an analog signal. So any value means, so analog signal can have infinite number of values. So definition is a signal whose amplitude, so very very important point, whose amplitude can take on any value in a continuous range, is an analog signal. So that means analog signal can have infinite number of values in its amplitude. So is an analog signal. Can take on any value in a continuous range is an analog signal. So that means we can say analog signal amplitude can have infinite number of values in a continuous range. Signal amplitude can have infinite number of values. So this is called an analog signal. See, continuous time signal is very simple, a signal which can specify over a continuous time. But analog signal means it should take, it represents amplitude, remember. So if it is amplitude is taking any number of values or any value in a continuous range, that is called an analog signal. So it can have an infinite number of values, it is an analog signal. Again, representation is same. So analog signal can be represented by x of t only, but there is a difference between analog and analog and continuous time signal. So I'll explain with the example. So remember this definition: amplitude. Now see, suppose this is x of t, suppose this is a signal. Now can I say this is a continuous time signal? Yes. Why? Because it is specified over a continuous time. That's what is called continuous time signal. Now, can I say this is an analog signal? Yes, because see, at every instant of time there is an amplitude. See, so many amplitudes, so infinite number of values. So a signal whose amplitude, say amplitude means vertical axis, which is varying or which is having so many values, infinite number of values. See, so many values are there and they are varying with respect to the time, continuous time. So I can say analog signal or continuous time signal. If I want to specify exactly, this is analog in vertical axis and continuous time with respect to the horizontal axis. Right? Now, one more example which can be called as continuous time, but it is not analog. So that is this one. So this is continuous time signal, but it is not analog. Not analog. So we'll say it's a digital signal, not analog, but continuous time signal. Why? It is specified over continuous time, right? At each instant of time there is a value. So that's why it is a continuous time, but not analog. So now, so I hope analog signal is clear. So a signal whose amplitude can take on any value in a continuous range. That means analog signal will have infinite number of values. So I hope it is clear. Next we will see digital signal. So very simple. So full Contradiction of analog. A signal whose amplitude can take on finite number of values. So a signal whose amplitude can take only finite number of values. Only can have, sorry, cannot take, can have finite number of values. Like suppose if I give a range 0 to 2 or 0 to 3, so it can have either 0, 1, 2, 3, maximum 3, or we can have 1 and 2, or we can have only 1, etc. So it should have a finite number of values. So finite means, so 0 to 10, if you are having 4 or 5 values, it is also a digital signal. But what is the contradiction is, if it is having an infinite number of values, it is called analog signal. So finite number of values. So if I take 2 values, so what is this signal is called? A digital signal. So what is the example? Very simple. So the digital computer will generate only 2 values, 0 and 1. That is example of digital signal. So we can say binary signal also, right? Binary or digital. I mean, the example of digital signal is the signals which will occur or which will produce by digital computer. So these digital signals, or we can convert analog to digital also. There is we need to study AD converters, etc. So digital signals provides digital computers. So which can have a finite number of values or fixed levels. So we'll see graphical representations now. So how to represent a digital signal? I can represent x of t, I can represent x of l, right? In discrete time signal, we can have digital signal. In continuous time, we can have digital signal. See, so this is the time axis with respect to n. This is the time axis with respect to the t. Now, finite values, I am taking 1 minus 1. So only 2 values. So we can have the signal something like this. Only 2 values. Example of digital signal. Next, 0, 1, 2, 3. It can be called as a digital signal if it is taking only 2 values. So this is 1 minus 1. See, it is having only 2 values, either 1 or minus 1 in all at discrete intervals of time, remember. So again minus 1, if you are having 1, yes, it is also possible. Minus 2, you should have only minus 1. If it is having a minus 2, etc., still we can say it is a digital, but we should see it is having a fixed finite number of levels, right? So in this case I am taking only 2 levels, 1 minus 1. So how can I give the names here? It is a digital with respect to the vertical axis. With respect to the time or a horizontal axis, it is a continuous time signal. Or simply we can say it is a digital signal also. This is a digital but discrete in time. Discrete time. So I hope you are getting the clarity here. So don't confuse. Any signal which is having finite number of amplitude levels Finite number means, or fixed means, either 0, 1 or 1 minus 1 or 1, 2, 3, only finite fixed level is 3. It can have, it is a digital signal. That can happen in continuous times or discrete time also. These are the examples. So both are digital in nature only. So I hope it is clear what is the difference between analog and digital, and what is the difference between continuous time, analog, discrete time, digital. Now I will give 2 note points, what this continuous time represents, discrete time represents, and what analog and digital represents. Then we will see the final summary on these classifications. So I am giving the note points, very very important, these 2 points. If you are clear with these 2 note points, you will never have any doubt on this continuous time, analog, discrete, digital. So what are these note points? The first one is about continuous time and discrete time. Now, see, continuous time or discrete time is with respect to the horizontal axis, right? If I am considering the horizontal axis, it is continuously varying, so it's a continuous time signal. If it is varying at discrete intervals, so it is a discrete time. So that means continuous time or discrete time qualifies the nature of a signal with respect to time axis or horizontal axis. Time axis or horizontal axis or x-axis, right? So continuous time or discrete time, so we should see the behavior with respect to the horizontal axis or time axis. If it is varying continuously, continuous time signal. If it is varying or it is specified at a discrete intervals of time, it's a discrete time. So that is the first point. The second one is, so analog or digital qualifies the nature of a signal with respect to amplitude or vertical axis. So analog or digital qualifies the nature of a signal with respect to amplitude, or which axis? Vertical axis. See, I hope you are clear with these 2 points. If you are clear, so you will never have any doubt on these classifications of signals: continuous time, discrete time, analog and digital. So analog or digital qualifies the nature of a signal with respect to the amplitude. If amplitudes are infinite number of values, analog signal. If it is having fixed levels, digital signal. Now a signal which is varying continuously with respect to the time, continuous time signal. If it is specified or varying at a discrete intervals of time, discrete time signal. Now all these classifications we will see 4 diagrams: analog, digital, discrete, continuous, etc. So please write down these 2 note points, very very important, and read 2-3 times, analyze it. If you are having any doubt, you can ask me. Right? Now we will see the final summary on these classifications with respect to graphical representations. Classification of signals: analog, digital, discrete time, continuous time. So I will draw 4 graphs. this is t, x of t. This is t, x of t. So you can able to tell if I draw the waveform. So please try to give the answers by yourself. What is this type of signal? X of n, x of n. Yeah. Now, so please tell me what is this signal? I can say very simple, simply it is an analog signal, right? Or if I want to give perfectly, it is, see, amplitude is having so many number of, right? See, every instant of time there is a different amplitude. So I can say it is analog in vertical axis, continuous time. Yes or no? At every instant of time there is a value. So it is specified over continuous values of time. So continuous time signal. Now one more. So I can say this is the, so it is having only two levels. If you observe, this is one level, I can say either 1 or high. So this is one level and this is 0 level, only two levels. No amplitude, there is amplitude, fixed amplitude. So there are two fixed levels. So what is the type of signal? It is a digital. But what about the x-axis? So it is specified for a continuous values of time. So it's a digital, we can say simply digital signal or digital comma continuous time signal. So continuous time signal. So I hope it is clear. Why it is called digital signal? Because it is having a fixed levels, only to 1 or 0. Now another one. If you take samples of this signal like this, see, amplitude is varying, so many values. So -2, -1, 0, 1, 2, 3. So we can have different values, or we can have negative values and so on. See, so 4, 5, 6 and so on. See the amplitude. Amplitude is taking so many values. So what is the type? It is, can I say analog? Yes. So it is an analog signal with respect to the vertical axis. But what about x-axis? It is a discrete time. So discrete time signal. So I can say it is generally when we study the signals and systems course, we will not talk about analog. We will say simply this is a discrete time signal. Yes, we can say, but if I want to exactly say, it is a analog in amplitude and discrete in time axis. So I hope it is clear. The last one, very simple. So if you are taking a fixed levels, so 0, this is 1, 2, 3. I am not taking any value, so 0. 4, again I should take the same value. Suppose this is 1, this is 1, this is also 1, this is also 1, and there is no value. So similarly -1, -2, suppose no value, -3, again if I taking 1. Can I say this is a digital? Yes, because it is having only two levels, either 1 or 0. There is no amplitude, means 0. So what is the name of this signal? I can say simply discrete time signal, or exactly means it's a digital and discrete in time. So discrete time. Now you may ask, see, digital nature, analog nature can have continuous time or discrete time. That is important, remember. So if if we go to digital logic design course or digital electronics course, we can say a clock signal, right? Clock signal is a digital signal, right? So we can say simply it is a digital signal, or this is. Now, and remember, all analog signals can be continuous time and not vice versa. Means all continuous time signals may not be analog. See the example. Sorry, not this. This is the one. See, it is in continuous in time, but if we are having only two values, so it is not analog. The amplitude is not analog nature. So I hope it is clear. So analyze these signals, and you can have different types of signals. Try to analyze yourself and see if you are having any doubt. Please ask me so I can clear your doubts. Right. So this is about the what is a signal and what are the main classifications of a signals. Next we will discuss the signal properties. That means if I take any signal, so what it will have, right? Or if I take a signal, what is the strength of that signal? How can I represent? So that we are going to see like a properties of a signal, or in that we will see what is the size of signals or strength of a signal. So for that we should know signal power, signal energy, how to calculate, etc. So that we will see in the properties of